Ever looked at an Arduino project and wondered, how does it actually do that? We're going to demystify it right now, breaking down the basic language it uses to talk to the world, from a blinking light all the way up to a complex robot. Yeah, so that's the big question, right? How does this little computer chip, this digital brain, actually reach out and interact with the real physical world? How does it make lights blink, motors whir, or even just read what a sensor is telling it? Well, the answer is actually way simpler than you'd probably guess. It really just comes down to a conversation. Think of it like this. The Arduino is literally talking to all the parts connected to it, but it's using a very, very specific vocabulary. Okay, so first things first. Let's look at the Arduino's senses and its hands. What I'm talking about here are its input and output pins. This is literally how it perceives and then acts on the world around it. See, every one of those little pins on the board can have one of two main jobs. You can set it to input, which is basically its ear. It's listening for stuff from the outside world, like, hey, is that button being pressed? Or you can set it to output, which is its mouth for shouting out commands like, turn on this light. So let's start with the absolute simplest conversation you can have. Just on or off. A simple yes or no. This is the digital world.
And in that digital world, there are really only two words in the vocabulary, high and low. High just means on, it's sending out 5 volts, and low means off, 0 volts. That's it. It's totally binary, a black and white signal, no in between.
Now, before a pin can do anything at all, you have to give it a job. You do that with the pin mode command. It's always the first step. You're basically telling it, all right, pin 13, your job is to be an output. You're going to control an LED. Or, hey, pin 2, you're an input. You're on button listening duty. Okay, so if pin mode gives the pin its job, digital write is the actual action command. This is the Arduino shouting on by sending a high signal, or off by sending a low signal to whatever pin you tell it to. This is the command that actually makes things happen. You want to light up an LED? This is how you do it. And you guessed it, if digital write is for talking, then digital read is for listening. The Arduino uses this command to check the state of a pin. It's basically asking, hey, pin 2, is your voltage high or low right now? And that's exactly how you'd find out if a button connected to it is being pressed. So that's really the crucial takeaway here. These two commands, they form the most basic conversation in electronics. Digital write is how the Arduino speaks, and digital read is how it listens. One sends out a command, and the other one reads the state. Simple as that. But the real world isn't just on or off, right? I mean, we've got shades of gray, we've got different temperatures, different levels of light. So if a digital signal is like a simple light switch, click on, click off, then an analog signal is like a dimmer switch. It gives you that whole beautiful range of brightness. So let's dive into that more nuanced conversation. This is the world of analog signals, where you can have a whole spectrum of values, not just a simple on or off. To listen for these kinds of details, the Arduino uses analog read. What it does is it measures the voltage on a specific analog pin, and then it converts that voltage into a number, somewhere between 0 and 1023. So that gives it over 1,000 distinct levels to work with. It's super sensitive. And that's how it can read something like the exact position of a control knob or measure the brightness in a room. Okay, but here's where it gets really cool. How does an Arduino speak in analog? The truth is, it can't. Not really. It can't actually output a variable voltage. So what does it do? It cheats. It uses the super clever trick called pulse width modulation, or PWM for short. And this is exactly how it works. Instead of changing the voltage, PWM just flicks a digital pin on and off super, super fast. The magic isn't what's called the duty cycle, which is just a fancy way of saying what percentage of the time is the pin on versus off. So if the pin is mostly off, an LED will look dim. If it's mostly on, it looks bright. Our eyes can't keep up with the flashing, so they just kind of blur it all together into what looks like a steady glow. The command for this whole trick is analog write, and with this one, you give it a value between 0, which means always off, and 255, which means always on. So, for example, if you gave it a value of, say, 128, that's about halfway. It means the pin will be on for exactly half the time, and that'll make your LED glow at about half brightness. Pretty neat, huh? And right here, you can see the whole conversation happening. First, the code listens to a sensor using analog read. It gets that number from 0 to 1023. Then, it thinks for a split second, doing a tiny bit of math to scale that big number down to the 0 to 255 range that analog write can understand. And finally, it speaks, using analog write to set the LED's brightness. It's this perfect little loop. Listen, think, and then act. Okay, so the Arduino can talk to its parts. That's great. But what about us, the people writing the code? How do we get a status report? How can we peek inside and see what the Arduino is actually thinking or what its sensors are reading? Well, for that, it needs to be able to talk directly to our computer. So the first thing we have to do is open up like a private chat line between the Arduino and the computer. We use the command serial.begin to do that, and that number you always see, the 9600, that's the baud rate. It's just them agreeing on how fast they're going to talk so they don't talk over each other and miss anything. And once that line is open, the Arduino can send us messages using serial.println. It can shoot back anything, text, numbers, the live readings from a sensor, you name it. And we get to see all those messages pop up right there in the serial monitor on our computer. It's like having a direct window right into the Arduino's brain. All right, we have covered a ton of ground. So let's just quickly recap the absolute core building blocks we just went over. This is really your fundamental toolkit for making an Arduino do, well, pretty much anything. Honestly, these 6 functions right here, this is your essential toolkit. They're the building blocks for just about every Arduino project you could dream up. You've got pin mode to set a pin's job, digital write to shout on or off, digital read to listen for high or low, analog read to listen for a whole range of values, analog write to fake that dimmer effect, and finally serial.println to report everything back to you. That is the core loop. So now you get it. You understand the fundamental vocabulary, you know how to make an Arduino listen, and you know how to make it speak. You can actually start having your own conversations between the digital world and the physical world. So the only real question left is, what conversation are you going to start?